Today we're continuing with day 15 part 2. We just saw part 1, and part 1 was simply using a Dijkstra algorithm. We needed to find the shortest path from a given point to the exit, and we have in each position a score, and we needed simply to find the shortest path. The ChatGPT was had almost no problems to implement graph algorithm, use position and so on, perfectly parsing and having the minimal path. One of the restrictions was that we weren't able to use a diagonal. We were not able to go from here. We needed to go up, down, left, right, and yeah, let's see how we'll do on the second part of the task. As usually, we are simply copying the part from the previous part, rename it. Our input file stays the same, our test file stays the same, our prompt more or less, it depends how we will approach it. I would assume that we simply will say, okay, thank you, your solution was working, but now we have this second task, can you modify it, the given task. And yeah, let's read the second part of the puzzle. Now that you know how to find lowest risk paths in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in a 5 by 5 tiles, and that forms the full map. Your original map tile repeats to the right and downwards. Each time the tile repeats to the right or downwards, all of the risk level are one higher than the tile immediately up or left of it. However, risk level above 9 wrap back around to 1. Okay, so if your original map had some position with risk level of 8, then the same position of each of the 25 total tiles would be as follows. We're going to here, and it's expanding to this one. That's 2, 2, etc. 3, 3, the same down. Okay, and the map will be humongous. Can now find the path from the top left corner to the bottom right corner with the lowest total risk. Okay, I see, but that's yeah. Let me prepare that. It's a bit too engaging. Let me see how much is that as a value. Oh, that's quite massive as a token. Let me give a try in the prompts. Okay, we'll continue with the same session. Let me say thank you, the solution is correct. you're now promoted to next level. You're given the second part of the task. You're given the second part of the task. Instruction: please modify modify your program to solve the second part with input blah 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 and task. I think it's simply too big. Let me cut off this bad boy, because we don't want to destroy all of our tokens and so on with simply having this map. That's more for people like. Yeah, I think that will be fine. Let's give a try. Okay, that's much less. Now let's look how it's modifying. Here the only part that needs to change is this shifting to the grid. We have this extended grid, and now the rest should be the same. Sorry about that. We have extended grid factor. I think in our case we need only to have the extended grid. We can stop the rest of the program, because I would assume that the rest should be the same, because nowhere was hard-coded limit and so on. And still, even with our big program, I think should be absolutely fine to load that in memory. It's not anything too big, I would assume. But let's give a try to the algorithm to see if we will complete it. If there is some mistake, I will simply use the part from the first solution and will simply adjust it to a match for the extended grid, or simply will implement the... Yeah, I think it's absolutely fine to do it as that. Let me have this part with the answer. The answer is not 0. We have this go program that stops here, but for us it's absolutely fine. We want to change the main function. Let me add in this info. For that, and I cut the input, because at the moment one of the biggest restriction, it's actually our input. Oh, we have it like no, I'm looking at another program. Sorry about that. I was thinking I don't remember to look like that. We need simply this extended grid. We don't the mean and so on, they're generic, and now this logic should stay more or less the same. Let me put the mean grid and let me try with the test. We're having 261 and we expect 315. Let's see how the extended grid looks like, because at that stage I actually will let me do that because we don't want to run, and let me have empty print line and still have the extended grid and the initial grid there. And here the initial grid has let me put an empty line to simply be easy for us to distinguish that. We have this 1162 and so on. Okay, that parts look kind of legit, but once we get to here in the extended one, we should have this one, because we have 116375 1742. We start with this part and we have 2 blah blah blah. Okay, everything is perfect. However, here we can see these zeros, which is not what we want. Here we shouldn't have zeros. Where is this here we once we go to 10, instead to getting the percentage, we'll need to check if we have 0, we do one thing, else we do no, actually exactly the opposite, and we do as simple as that. Okay, and now when let's double check, now our should be 86, the bottom one should be 79. 6 9. Why is this? 2 3. Let me see how it's going. Now we have it correctly in one of the directions, but how it's going when we have it here like a 2 2, after that we have it like a 3 and so on. To me it seems once we complete this one we are going down to that one. Yeah, I would assume so, but do we do that part? Doesn't seem so. Let me see extended grid. We are doing that with the columns. We are the first row. However, here is okay, the factor is 5 because we need to extend it 5 times, and that's with rows and that's with columns. But firstly we go to here and going through all of the columns, which is fine. But wait a minute, we need to do that with the 0 1. Extend it I don't think going after the row by row it's correctly done. Am I missing something? I think that part is simply not correct. That's the first row. Where are, let me do it when I'm doing this print here where I'm printing. I actually want to print only the first one, and that should be this bad boy. That's correct. What about the second one? 2136 up to 62. 2134. Why is not ending on 63? 57, but this should be 3 here, exactly in the same way as here. That was 6. Let me double check again if that's what's going on there. Okay, here it's 6. Why would it be on position 2? Not to translate this stuff. But wait a minute, why on earth I have this additional stuff? Don't like okay, that's counting where I'm here and here, but for me will be much easier to simply get this extended rows have these extended columns, do it for the first no extended, and after that for the following one looking a little bit. I don't like this part here. Let me go again. Look a little bit at the second one. 1 to 6. I can see here is, yeah, that's simply wrong. Okay, let's do this a little bit different. Let's ask Bing for this stuff. And let's do the following thing. I have an array of single. I have 2D array of single digit integers. I want to expand this firstly by increasing the number of columns 5 times as on each step I get the original number and increase it with 1, and whenever is bigger than 9 to set it to 1. I want to do that for arbitrary array in Golang. Let me get back to my prompts. I am here and I have prompt Bing. My array, my initial array is called grid. Could you write me a snippet of code who do that? Okay. Let's go Bing. Okay, let me go to chat with Bing. What is Bing doing? I have my grid that it's 1, 2, 3, 4, 5, 6. And I'm whooping through the grid. Into which one? Well, 1 second. Because the Bing here increased my number of columns with 5. Let's see. Go. Tuk. Answer. 5 by 5. One second. I think that to increase the size of the array five times, not with 5 more columns. And okay, now let's get that. I think is this is legit. Prompt, sadly not Google, sadly for Google. That's the answer. Bam. Boom, boom, go. Nice. And my stuff was okay. No. That's the first part. Here, instead of doing this stuff, I actually would prefer to do this. The only difference is here I want to add I. That theoretically second 2 3 1 which let me look at the first row. No, it doesn't. But wait a minute. I would want this extended grid. To the extended grid, I want to I want really to append a new row. I want to make a much bigger row, because what I want to do is having this row and simply have it 5 times. However, here that's my new row, so to say. And for my row, what I want to do is to have a loop that is J, is it J? I'm getting here this first row here, and counting when I hit here 0, getting more and more fuse. Let me see how this 0 is working. Okay, that's exactly this one. I want to have this one exactly. Here it's my J, but to my J now we want to multiply that by 1, and for all of the values here I want to have J 0. Because here with these indices I want to have, let me look, 0, 1, 2, 3, 4, 5, 6, etc. And I want to do that, for example, if I have this 3 1. I want to have this 3, after that this, and so on. And that should be for this given one. It should be 0, 1, etc. But first you will have these zeros, after that, which means I can have the j. After that, actually we'll need to have my j multiplied I will go because how to get to 3? I will start here 1 and here again 0, how to make it to 3? Here I'm like 1 second. Am I like fucking moron? Sorry about the language. I was thinking to do something super clever, but yeah, each person that try to do something clever, at the end of the day does something wrong. Okay, for doing the first row, I have my k. I'm increasing it of this tab. I'm adding for the beginning 0, after that 1, 2, 3, and checking. And I'm returning this one, but wait a minute. I'm making in this way only one row. Let me see how is that working. But wait a minute, why I have this 1163, which is the correct one, but at the wrong place? see here. Now actually that was perfectly fine. I can see in this moment I will need to have this which is actually correct. Now 186 or no 1623. Why is that 186 not 2? Five, five, five. I'm a bit puzzled here. I have this 286. Why this 7 plus 4 Okay, I see. I'm failing in the same trap. If it is divided by 10, it's not 0, should be like that, and else okay, let's do my now whenever it's equal to 0, if it is equal to if this is bigger than 9, if it's not bigger than 9, we are doing nothing, we keep it. But when it's bigger, we do that plus 1. Okay, that part is okay. Now we have the first row. Whatever we do for the first row, we would need to have that stuff as to step, step, and of this man. Of that stuff here be like that. And this should be rows. Because that's the entire grid. Here, let's see how that looks. Yeah, that's looking wrong, because here simply need to do this thing, and now 138 up to this 231 and 359. Okay, we have it up to here. Which is perfectly fine. And here I would imagine that actually we need this one. Doesn't make any difference. Now we have this extended element, and we want to do what we were doing here with the columns, we want if I have it like that, okay, but can I simply do it like that? Oh man. And we want to go through all these rows and simply copying them. Okay, let me see. Column. If I have the columns, let me, sorry about that, I was thinking here how to do the routing. I need to start my new K that is from this row here. Okay, in this moment I'm going through all of these elements. There's, so to say, the extended element, and I will want for this element to actually place each of them in this for each of them I'll have again step. This time I will not be this kind of step. I would imagine that that will be here. Is that correct? I do my 5-step. I have my extended comb actually. And yes, should be J of this bad boy should be J. And I'm here at this one and I'm trying to copy it to this one plus 1 multiplied by the step I want to have that rows but not extended one. I'm going to this one and going I want this one to be like that. I'm starting from 1. I have this one, 2, 3, 4, 5. I would imagine that here should be 4. And what's wrong with that? Because here I'm finding where actually here on the new grid I should have J. No doubts in that. One second. Do I really need this super complicated stuff? What about if I use K and J and J? And here I actually have this one. No, actually, exactly, I have this K and J. In this one, I should copy it here. Yeah. Okay, 479 and 165. Okay, that's look legit this time. With, I mean, this looking at the grid, and this stuff so nice, but let's three, 1, 5. Okay, that's our test input. We don't need these bad boys. And we need our ginormous input. See if everything will. Why we see this print stuff? Yes, because of this one. One second. Let's see how long will run? Yeah, it's and our input is ginormous, but still our program doesn't use a lot of memory or anything like that. It's a bit slow, but I mean it works. I think 40 seconds. Probably there is some way to optimize that. We definitely don't want to do this stuff. Div is our inputs. What we have as our input here. I think actually the first input we with some worksheet. Yeah, this definitely should come here actually. Having it like that because it's not complete, and actually having this checkout. This one. Okay. Anyway, that's a detail, but we were able to solve part 2 day 15 and hope to see you in day 16. Have a nice one.